Okay, good day, everyone. We're glad to welcome you all to this session. This is part of our webinar series we've been doing. This should be the first session, and today this is actually a collaborative effort between Blaze 360 Human Virtual Tours and Leica Geosystems. So today we'll have Dr. Satendra Kumar to take us through laser scanning for AEC, Architecture, Engineering, and Construction. I'll be handing over to him so that he will introduce himself properly and take us through the session today. And before we get started, we will advise everyone to kindly mute your mic and disable your video so that the session will be clear enough. And if you have any questions while the presentation is ongoing, feel free to type into the chat box, or you can also identify by raising your hand so that as soon as it's done, we'll have an interactive session. So thank you all for attending this webinar.
Thanks for allowing me to join this webinar and then connecting me over here. I hope you guys can listen me. Am I audible?
Yes, we can hear you.
Okay, that's great. So basically, my name is Satendra Kumar, and I'm a basically public safety and AEC BIM market manager for Leica Geosystems, responsible for Africa's Middle East and a part of Asia. I take care of laser scanning division, in particular to construction and the industry, which is for police and defense. In this webinar today, we will be learning about how 3D scanning can actually be implemented in BIM and how it helps. Everyone in Africa, we are knowing that we are digitalizing the buildings. We are going for digital workflows so that we can construct buildings much better way, much smoother, on time, and with various factors for as-built designs and consistency across the different contracts and subcontractors, so that we can manage the different stages on time. So this one word always keeps on coming in our mind when we talk about BIM. What kind of BIM you need? What level of BIM is required? We divide it into LDs, like level of details, at different positions, and then later on we ourselves feel like where exactly the BIM starts. Do we start BIM in our office when we model something, or do we start it once the building is done and we capture as built and then we do the modelings? So all the segments, all the aspects of a construction, which is on a real world and on the digital world, together they make it BIM. So basically, by using BIM, what we are trying to do is we are bridging something between the office and the real world. Because as on today, what we lack is the things those are going on construction and those are in our systems have a huge gap. In any kind of infrastructure, starting from the stages where we start the land to make it ready for the construction, until edge built, and later on for the facility management, we always lack the right information of field to the office. And there is a big gap where we keep on jumping right and forth, which makes us to revisit the sites again and again, and unnecessary expenses during the construction as well as the maintenance. And this makes a huge impact on that. So by BIM, what we can do is we can reduce this gap, and then we can actually merge it together, and we can start working on better projects, doing better analysis, and then we'll have less complications during the project stages. When we talk about BIM, we have two other options. One option says you go on site, collect the data in a normal conventional method, which is basically an analog approach, where you go with scales, note down everything on a notepad, and then later on come back and do a AutoCAD design or a Revit design based on those dimensions. Another way is a digital workflow, where you just go, take the device without any error, without any changes in the dimensions. Every time you make, you can be more accurate, and you can use the digital platform. But since last few years, digital platform is there. We have analog systems still going on, but they both were failed at a stage because with total stations, with distos, with all measurement devices which were existing, had a limitation of capturing 1 point or 10 points. And even in the robotic total stations, those have come in market few years back, have a capacity up to 10,000, 15,000 and 25,000 points per second. And that was not enough to capture the edge build. That was not enough to capture the complex geometries of your heritage sites, your facades, your buildings, those were around us, and on the even on the refabrication as well as the construction monitoring stage, we needed more points. We need more measurements so that we can be more accurate. And that's the reason new devices came in between. And in 2009-10, we entered in a market segment, though the scanners were existing since last 50 years, we can say 15 years, but the thing came in our Excel. This thing is, scanning came in extensive utilization by around, we can say 2009-10, where all these construction industries decided to go with 3D laser scanning at various levels based on the criticality. And after 2015-16, it became our normal workflow for every building to have BIM modeling. And these devices, you can see the scanner which is on the right side, the Leica BLK360, the smallest scanner, got launched in 2017. And this scanner was supposed to capture 360,000 measurements per second, so that you get a measurement of everything which is around the scanner. That we will discuss later on the next slides. And in 2017, later on, we feel we got a huge revolution in the digital construction because of the involvement of international brands working together. It's like some mega projects, like if we say the Dubai Burj Dubai, or we have Museum of Future, we have few other remarkable structures got constructed. Even if we talk about Nairobi, if we see, we have the PwC building there in Kenya, in Nigeria we have buildings, airports. Those all started, and the contracts were with the different organizations belonging to different countries. And everybody cannot come on the field and can start work from zero. So we needed a advantage, or we can say we needed something to capture everything in 3D, to have more accurate measurements, to have more accurate edge built, so that it can be sent over internet or sent via servers in a secure network, so that they can view and access the information and can later on compare the things and do a mock trials based on that, how the building will look like, what will be the areas required, how much is the clearance required on the sites, so that they can see the ground truth. But the problem which we faced, like everyone was eager to learn something. They were needing a more accurate BIM model. They were needing more and more information about that building. But we were using Stone Age tools, and that was not possible for us. It was clearly not possible for us to actually have this thing in our consideration, that we can measure each and every detail. So what we were using at that time were the Stone Age tools. We had these kind of tools, and we were trying to capture the measurements, and for big mega structures it was not possible. Post that, the modern infrastructure came. So if we see, this was the tools, those were from the past, but we still acquired them. We were still using them, and they were not sufficient to get us the most of the information which we needed. So what we did is we switched, and we tried to take some of the equipment from the future which came that time, starting from 3D laser scanners. We started using 360 photography, digital laser scanners and distometers across. And in current scenario, we can say we implemented new further technologies like augmented reality. We implemented artificial intelligence to understand where the project is at what stage, how much time it will take, what are the accuracies of the constructed sites as on today. So to understand all those things, we started implementing new technologies, and we called it like a reality capture. We want to capture whatever is on the ground and whatever is in the BIM, and then whatever is in the Revit model, and then we want to compare them all together. Why? The reason was to implement this technology was we did a survey, and various other surveys came across the globe from different magazines as well as different construction industry experts. And they did an analysis in 2017 that 100 top UK construction companies collectively made only 1% profit margin, which was very paper thin. And the problem was they cannot optimize it more. They were running at their maximum capacity, they were running at their maximum optimization on the existing scenarios with the existing tools. So they decided to implement, let's go for a digital reality, because that was the only option left to increase the margins. Because you cannot increase the rate of the project, you cannot increase, because if you want to make some more margins, you have to either reduce the price of the raw material, or you have to increase the end customer pricing. And customer pricing was not possible to increase because nobody was ready to buy it more. Competition was very heavy. And in the second part, the construction material will never be gonna cheap, because it's inflation, as well as 100 other buyers are actually looking into this. So the best way was to optimize using LiDAR scanning, using BIM modeling, that we use the minimum required construction material, the maximum accuracy, and no mistakes on the site, so that we don't have to do any read and work, or we don't have to redo anything on the site. Everything has to go as planned, on time, and then only we can make margins. People did this practice, and if we see a minimum EBIT margin in last 5 years, which was compared in Australia, it was around 4.5, in Europe it was around 4, overall global it was 4.5, but UK and US was going down. They were actually getting around 1 and 1.5% of the margins. Why? Because in European countries, BIM got implemented much before than US, and then everyone analyzed that we need to go with that analysis. Few of the companies decided in the first shift, like we can say Skanska, BEM, then we have Samsung, we have Hyundai Construction. So there were few of the construction companies, those were really took advantage of the first step, and then they joined this league so that they can actually be pioneers in this field, and this helped them to increase their margins at different levels on a project site. And later on, what they understood is it should be implemented across their all verticals, so that they can work better way with their contractors, with their subcontractors, and all those things. And it will help them to close the project on time, because now they can estimate the project timings much better way, because they know what height, what verticality, at what speed they are running. If they have laid down a floor, what is the flatness of the floor, what is the height of the building, what is the verticality of the building, how good it is with the BIM model, which is a Revit model. So they try to make a combination of 3D scanning running on a construction site and comparison with their BIM models on day-to-day basis, so that they can stop a mistake from happening at a very primary stage, so that they can control time. Once they control the time, another factor was it should be in budget. And if you are not on time, the inflation will keep on increasing. You will have more money to invest on the raw materials. So if it is on time, they saved on the budgets, as well as they calculated the material, because BIM model was available. They can do volume calculations, they can do all trajectory analysis, they can do all verticality, as well as the clearance analysis of the building. And subcontractors also can start working on partially constructed sites for the second phase or third phase of the buildings. This saved them to have a better thing on budget. And the third, or the most typical part of any project, is once the project is done, is it on specifications? Is the auditor verifies that yes, this particular project is done on a very accurate dimensions, it is as per specifications, be it a road or a building. If this is not as per the specifications, the problem will come in occupancy certificates from the authorities. Even the company who gave the contract will not pay you more, because there are liabilities and there are LDs for this thing, so that if you don't make anything on specifications, you have to pay price for that, and it will reduce your margins. So to make it on as per specifications, they implemented 3D technologies there. And then Leica did a wonderful job working together, because Leica was manufacturing measurement and construction instruments since 200 years now. Like 1818 Leica started basically, and they got this name Leica Geosystems in 1919. Before that, it was with various names like Wild Huberg and all Khan surveys and all. So at the end in 1919, when Leica was making measurement equipment starting from your theodolites, measurements, total stations, we understood this problem well before, and we tried to make a combination between the model world, which an expert or an architect has modeled, and with the reality at different stages, and tried to make them merge with each other to understand various aspects of a construction site that were before construction, monitoring how you have to prepare the land, how much is the clearance, what is the area, what are the areas where you have to go for cut and fill analysis. So all these things were done to make a better project where the architects can understand how the building will be and what are the impacts on this, as well as the contractors were knowing where to construct, what to construct, how accurately to construct. So keeping them informed from the stage of we can say the starting of the project or pre-construction. Then when the construction stage was going on, in that case, comparing your existing model with the ground structure, so that you can understand what you have constructed is as per the design and as per the specification, so that you don't have to redo the work, you don't have to do any mistakes and then spend money on that correcting them. And then the third was validating the as-built designs, because if you look at one aspect, that if you have constructed a concrete structure as per the structure which is made in the BIM model or in a Revit model or AutoCAD model, it's not sufficient to make a building running. You need to have emergency evacuations, you need to have HVAC lines, you have heating, cooling, fire things, or as well as you have to have electric installations. So having all the facilities are modeled by different guys on that particular model, and what if they clash together, what if they are not optimized, that might create a big trouble at the later is not only the construction of the concrete but also the construction and implementation and installation of other AEC and HVAC components. So this allowed to validate these models which you have done for HVAC and all other aspects of the facility management together with the construction side, and then see them how accurate they are. It helped starting from informing, then enriching it. So what you can do is with the solutions is basically, if you go with a 3D scanner or any robotic total station, you can capture the ground reality, what is on the ground. You bring it back to your model in the office, decide what needs to be done, and later on you can push this data using Leica Infinity and all other solutions to your total stations. And now your total station is your as-built, or you can say your BIM model, your Revit model straight sits on a total station. And once the site is constructed, you can go with a mobile mapping device and you can do a validation depending on various sizes of the project. The project is small in a shopping mall, you can go with BLK. If you have constructed a 100 meters road or a big shopping complex, you can go with a mobile mapping solution, and then you can validate those structures. So based on the requirement of the project, we decided that let's make different components and different reality capturing solutions. Because if a scanner which is scanning a kilometer range, which is on your extreme right, if you see a P series, PXX, if a scanner captures a kilometer range, is always not required for a small job, which is just a room. So we started working on different aspects and we made solutions. Like if you see on the center lower part, it's a BLK 360, a scanner which captures just 60 meters with 360,000 points with a millimeter accuracy, along with thermal data, which is good for an interior designer or a person who is constructing a building for 3, 4, or 5, 6 floors. So for them, the solution was designed meeting as per the requirement of the customers, with a smaller laser scanner with 60 meters, then for 130, then 270, 480, and then a kilometer range. Few projects were very tricky where you cannot go with the scanner. You have to construct a dam, or you have to go for a survey of the very big site or a golf course or any other mega structure, you might need a drone. So even we worked on mobile mapping solutions, and we made few of survey grade drones, which you see in next of you on the center up. It is a AX20A bot, which is fitted with a survey grade GPS solution, which gives you a very accurate 3 to 4 centimeter accurate photogrammetry, which is not accurate as 3D scanners with millimeter 1.8, 1 or 2 millimeters, but it is few centimeters, but it can cover more area for doing that same job. Then there were few requirements of construction, like if you are making a road, these scanners will take you forever to do a survey of 200 kilometers road. In all those cases, vehicle mounted independent scanners were designed. Those were for mobile capturing, so that you can run up to 40, 50, 80 or 100 kilometers per hour, and you can capture the data depending on the density what you need. This was all about capturing something above the ground. But for a construction worker, the pain is not what is on the ground, because he can see what is there. The pain, another part, was what is below the ground. You are going to construct something, and by mistake you cut a telephone line, you cut a power line, you cut a we can say utility line, which can be water, which can be a sewage. So if you mesh with any of these things during excavation of the project site or the construction site, you might end up paying very heavy fines to the municipalities, or to the construction site, the repair might cost a big amount, which will reduce your margins. So even we implemented few solutions like GPRs, DS2000. Those are like a ground penetration radars with multi sensor antennas, so that you can understand what is below the ground. So before digging on a construction site, you should be sure that you are not hitting any utility which might cause problems with you in the later future, so that you can actually have a reality on ground analysis, what is above the ground, what is below the ground, how it meets. And there are times when you are constructing and you are doing an underground sewage line and all those things, where you are not aware what is the next line, and you might hit the another sewage line when you are doing. So to do this kind of survey before that always help the construction companies to save the margins, to increase the margins, and to do the projects on time. We at Leica call reality capture as digital realities. So we call digital realities means whatever was in reality, we captured it with the help of 3D scanners, GPRs, airborne sensors, and then we made it digital, so that you can run around, you can open it in your laptop, you can open the same thing on your mobile phone, you can take it on the field, you can put it on augmented reality and can see on the field. So we made whatever was reality in. So it was a video which was showing how the construction has worked. And now how we have used the reality capture is the question. Like, we have captured everything in 3D and we wanted to use this. So in this, there are various ways where we can use this BIM structure. We can use it for analyzing what is there in the site, how to change them, what are the dimensions, and various aspects were like, we can use it for as built modeling when we want to model object from a actual site which is on the reality, which is an old construction site, or it's a construction site which you are working currently, or it might be a heritage site and we want to have as built models. We can do deviation reportings based on the floor flatness, sites, tunnel analysis. We can have volumetric analysis for cones, cylinders. We can have analysis for the fuel storage tanks. So all these started working for the deviation reporting, as well as for the clash detection, and at the end sharing the data with various stakeholders so that they can understand there are changes there. It allowed us to have an actionable reality, digital reality, where we can work. So this is a perfect example where we talk about, this was a building which was constructed few years back, and then the construction company has decided, okay, let's make some partitions in the office. So they made some partitions across the office to accommodate various conference rooms and different cabins for discussion. And this information was never informed back to the BIM design guy, and this created issues. As well as when in the second stage we want to decide what is constructed on different sites. So this is a BIM model, or this is a scan which is captured, and now you can go for horizontal and vertical slicing of the building to understand at what level are different solutions, different layers are, where the building is constructed accurate, what are the areas where deviations are more, what are the areas where dimensions and deviations are less. So we can actually do this comparison without even making a BIM model from the site. We can straight away compare our BIM model with the 3D scanning, 3D data. It allows you to have not only this data, but have a complete 3D picture of the area so that you can walk around. It allows you to see the spaces between the spaces, so that if you miss some space, you can actually go back and then see this space back. You can virtually visit your assets and construction sites whenever you want on just a single click, and then you don't have to go back to the site. Post that, this is an example where it shows how we can do a BIM modeling. So this is what we are working on a Revit. So this is a Revit software. In between, what we did is we have loaded a CloudWorks, which we captured from the field. So these orange lines, we can say, you see, is basically a point cloud which we captured, and now we are tracing the point clouds using the CAD tools or Revit tools together, and then post that we can actually do as-built modeling for the walls, for the ceilings, for all the area of the building at no hassle. We don't have to worry about what dimensions we are using, are we correct or not. We just have to follow and trace the point clouds, and softwares are smart enough to actually draw those things for us. And then later on we can have a complete model where we can work on base design. If we have a base design, we can accurately do that and do analysis on the reality. We can do model. If we want to model something, a particular part of a building, we want to model, it can be a HVAC room, it can be a generator room, it can be a cooling and ventilation AC ducting room. So in all those areas, when we particularly want to refurbish, or it can be a small shop in a shopping mall, out of the whole mall which you want to refurbish. So you can actually model that particular part of that project. It allows you to validate the existing models if in case there are deviations. This is a perfect example where we see if we have any clashes or we want to model a pipe. So this is where shows if you want to model this particular pipe in a building, you are not interested in all of the project, but just the pipe. In that case, you can use the tools like CloudWorks for Revit, and it allows you to actually put all those dimensions based on the point clouds on the reality, and you can choose between the data sets and the options available in the Revit library, and you can model it much faster and much better way than what currently we are doing. It allows you to have an option for best fit geometries to the clouds. It is semi-automatic process which eliminates the errors because you select the components and then automatically it fits the geometry to the point clouds to get the most accurate data. It increases the productivity in modeling by almost 50% of your current efforts. There are few sites where it is not only important to measure everything, but to do an analysis, especially on bridges and the construction sites where you have dams and all mega projects. This technology even allows you to do a validation analysis based on the tolerance. So that if you are constructing a bridge, you are constructing a dam or any other such critical project where accuracy within a millimeter can actually make a major difference, you can do those analysis based on your BIM models. So we have loaded the BIM model and the construction site together in this particular scene. And now you can see that the analysis is done by software automatically to tell you what are the heat zones, what are the areas where the construction on the ground is not as per BIM. Though it is a millimeter level difference, but it can also be highlighted based on your project requirements. It can be a road, it can be a dam, it can be any other construction site, it can be a big building. It allows you to have identification on the potential issues which might occur once you are at a later stage, like a deviation of 1 degree in a building or deviation on analysis of a dam. Once you start at a primary stage, more you grow on the building or on the project, the mistake keeps on becoming big because the chances of correcting that becomes very tough. And in all those cases, it can help us in pre-identifying the issues that might occur later on the stage. It validates the positional accuracy and allows us to easily understand with the visuals that where we are going wrong. It can be just a floor flatness, but later on, once you have constructed the whole floor and it is not perfectly flat, it might cost a lot during the maintenance of the particular building. So in all those cases, we can use this technology. There are few cases where we have one design for HVAC came from one contractor who is working on installing these pipes for AC ducting. Another company is making a construction of the building, and they both have never spoke with each other. They both were given different contractors by a main contractor, and they never bothered to talk and understand each other's geometry. They just had all different components ready, dissected, cutted as per the dimensions. And when they reach to the site, they analyze and they identify, oh, this cannot be done because the construction company has done another pillar on the way, and now the existing HVAC plant doesn't work. And this might be costly. And the same way, there are few things where the people do those changes. The subcontractor for the HVAC does the changes and doesn't tell the BIM design guy. So those are unmeasured always. In all those cases, if there is a clash, this solution can help us out and do understanding what is clash, where is the clash, and this clash can be between 3D model against the point cloud. It can be in the tolerance, it can be higher than the tolerance value, or it can be lower than the tolerance value. And anything which is higher or lower, both will have an impact on the building efficiency. So it can help in that identifying the clashes before they go. By doing this clash, what we can do is we can identify the clashes between design models and real world scans. That helps us in avoid costly mistakes. We can ensure the compliance so that our project gets passed from the authorities. We can even have a validation of the quality for the models which we created from the point clouds for the base design, so that we can ensure that the base design is accurate and we are running on the project with a accurate analysis. Same way, these things can be done for anti-clash as well, because we want to install all components without hassle in the building. But on the another term, we just don't want any additional component installed which has no relevance. So if in a whole analysis, if something is missing which is not installed, or something which is installed and we don't need in that particular building, can also be analyzed using an anti-clash and clash modules. Like in this example, if you see, as per the BIM model, there was supposed to be another duct here, which is shown in the red. But the duct which is installed on the real world was only the one which is above. How do we identify those kind of changes? because everything is on a construction phase, and being humans, we cannot measure and we cannot take everything. So in all those cases, scanning can help handy, and they can run an anti-clash automatically and can tell you what are the components those are in the BIM model, those are in the Revit model, and are not implemented on the ground. So that before you go for the building validation from with the external contractor, you can verify your things. Sometimes we don't observe few structures. Like if we see in this image, these pipes, both those are highlighted. They are not on their right positions. But as a human, if I go on construction site, I see my map and then I see where is the pipe. I see, okay, the pipe is installed. I'm okay with it. But when you have to join this pipe across the wall on the other side later on, you might put holes onto different positions and they will never meet each other. So in all those scenarios where the reality is different than the modeled one, then can cause a very heavy costly affair on that mistake. So to avoid all those things, also we can use this kind of solutions where we can use it for refurbishment, we can use it for installing new utilities, and that helps a lot. This is another example how we do a construction monitoring. So if we see in this example, the pillar here highlighted in the magenta line comes in between the installation, which makes this particular plan not available to install or not possible to install. And that can be an issue on the later on stage when we go for the building completion and later on when we try to install all other additional components. So that can also play a critical role in avoiding those mistakes. It automatically identifies the clashes and the pre-construction sites. It validates the ongoing construction so that you don't do any mistake. It allows you to correct your mistakes before they happen, and then you can stay on time and you can stay on the specifications. Another aspect comes here, which is nowadays coming very importantly, that the companies across globe are getting jobs for refurbishment as well as to do a reconstruction of the heritage buildings, and they cannot visit every time to the site, and especially the times when now we have COVID-19 hit us badly. I'm sure there will be lots of projects with all your construction companies that you guys are waiting because you cannot go to the construction site and do the verification of all those aspects which you want to design, which you want to do a prefabrication. But if imagine you have done this scan, this data, and the data is with you on an earlier time, or somebody who is still working on that particular country can send you the data. If that data comes, you can actually visit that, putting on a cloud, or can have a local on your computer system. Later on, you can visit like you are actually on the site with accurate measurements. You can measure dimensions, you can measure all whatever is required for this particular project to refurbish. You can take angles, you can take horizontal and vertical dimensions of the site. This shows you with the third digit of a meter in, I can say 1.8 to 2 millimeters. In some cases, when you do a very high resolution scan, it can go up to 0.8 millimeters on the measurements. It allows you to share and collaborate online so that two architects can sit together and they can analyze from two different geographical locations about that particular one site. They can avoid costly visits on the site, especially in current situations when the time is of health hazards or even the costly affairs for the travels. We can use and reuse this same 3D data for even when we want to reconstruct it back after 5 years or 10 years. For the companies, those are involved in long-term maintenance contracts can use the same 3D design at various stages of the time and can use it as a document which can be a reference document forever. There are few projects, those are examples where the BIM projects were designed along with together. So the Waterford Courthouse was designed and then a pre-construction as well as the construction phases done using a Leica 3D scanner, which was P series. And today, if you have heard about, or if you have not heard about, just Google about this project. This is a project called Museum of Future. So this is one of iconic building which is running completely on a metal structure, and the loop has to meet. Any millimeter level error on any point of the construction phase can actually make this whole project look ugly and not getting it finished on time. On all those analysis, BAM Constructions decided that every component that will be analyzed in this particular building will be verified and measured at various stages, so that you can always have this data, and they are verifying it on day-to-day basis, so that they can meet the requirements and do the building on complete specifications. There are a lot many other projects running across globe where 3D technologies are getting used. For a small contractor who just does jobs of AEC installation or just having a ducting installation, can have a interior refurbishings of the installation of various other components, can use a small scanner like BLK 360, where you can compare your reality along with the installed components and the Revit model, and you can see what are the components those are missing and what are the components those needs to be installed. This is all about what we can do. So with BIM, there are a lot many other uses where we can push this 3D design data up to machine control devices like dozers, excavators, and all those things. And we can construct the roads as per the BIM model using all automated workflows if we have captured the BIM well. I open this webinar for a question and answer session. So if in case anybody wants to have any questions, you can just ask it here, or you can reach out to me.
Okay, thank you very much, Dr. Satendra, for the insightful presentation. So in the course of presentation, some questions were asked. So we have about 3 questions already. So I will just read them the way they were asked. So the first one here, I believe you already answered that in the course of presentation. It says, can you scan all elements, architectural, structural, and MEP of an existing infrastructure using the Leica laser scanner? For example, scanning a pipe embedded in a wall. So if you can scan elements of an existing infrastructure.
Yes, you can scan all the elements that can be architectural, structural, MEP for any existing project, and then post that. So we have different ways. One way is we can scan what is exactly today. So you might get a project to have a heritage restoration or a MEP installation where already MEPs are there. You can just go and then scan the whole area, and then you can keep that as a reference. You can do a BIM modeling, or you can do as-built modeling from there itself. So it can be used at different stages. If you have BIM model, you can use it for monitoring and validation. If you don't have any model, you can straight away go with a scanner in hand, can scan the site, bring it back in 3D, and then later on you can start modeling over it.
Okay. I hope that I've answered the question.
Yeah, so the another question.
Okay, the second one here says, okay, you can see the question. Yeah, he said, does this allow sharing of your scan model via cloud-based app so as to enable stakeholders view and comment on the model?
Okay, so for this we have 2 options. You can have hard data, basically we can say offline data on your computers, which you can share with anybody, or you can come to a cloud-based. We can have Leica Geosystems have LGS enterprise solutions. Those are cloud-based applications where you can upload your 3D model and a laser scan, and all over the world you can have access to it. That have 2 different modes. One with Leica, which is available, is you can host your projects with Leica Cloud. Another way is you can buy an enterprise level software solution. You can install it on your local server, and then you can control that with your data as much as you want. So it has all options available where you can share this data, and this data can be viewed on mobile phone, can be viewed on computers. Even there are options where if I have one 3D model scanned available here in Dubai, and you want to work on Revit on the straight model, you can straight away access this 3D model using your machine, and you can start modeling on Revit sitting there in Nigeria or in Ghana or in Kenya, wherever you want.
Oh, okay, that's great. Okay, the third question here says, we have successfully used Leica scanner to do site surveying. However, on a 10-kilometer pipeline project, it was quite tasking moving the equipment from one point to the other. I'm wondering if the car-mounted scanner I saw in one of the slides will help.
Okay, so the thing is, I'll tell you there are 2 things. One thing is, if you are doing this 10-kilometer survey with a pipeline on a terrestrial laser scanner, It is possible depending on how you have done it. So there are various ways with scanners where you can go with targets, or you can even go with GPS based analysis. But yes, mobile mapping solution can run up to 50, 60 or 70 kilometers per hour and can capture this. It has its own survey grade GPS as well as GNSS receivers installed on the device. It has its own IMU sensor and a 6 camera mounted camera system as well, which captures the images. So in total, when you talk about this, you can just mount it on your vehicle and you can run for like 10 kilometers. Will take hardly, I can say, uh, we can say 10 to 15 minutes to capture the whole data, and the data will be very accurate and it will be geo-referenced.
Okay. All right, that's great. I'll have another question. It says, sorry, I came in late. Does it mean that the scanner will be installed on the site? And how do we install it, and at which position can you install it?
Okay.
Yeah.
In this, the thing is, scanners are handheld devices. Those are free to move. So you can just go on a site, put it on tripod like a total station. This is basically like a total station. The difference is total station captures 1 point at second and you have to manually operate it. 3D laser scanner captures 360 with 1 million to 2 million points per second with the same accuracy, and you can install it anywhere on the site. So it doesn't have a particular location, so you can put wherever you can have this site and you can use it. And there are few organizations, like if you say Human Virtual Tours 3D, and then Leica itself, it has its own offices where local experts can actually help you. Once you have the scanner, they can train you how to put, how to scan, and then they can use. And for this construction, if I say, this webinar was launched together with a 360 Human Virtual Tours company running out of Nigeria, and these guys can actually also help you out in doing these kind of trainings and all wherever you need on the region.
Okay.
What are the legal issues you have come and count 3D scanning in construction? Okay, so in construction of a concrete, we never got the legal issues because it's class 1 laser, which is safe for humans to use, and that is not having any legal complications all across globe. But yes, if you want to go for a plant like oil and gas industry, then in that case you need to have a intrinsic safety certifications. Those has to be acquired. Even in cases when you go for road accident crashes, there are certificates from NIST. So those certificates, based on the customer requirement of the projects, can be availed. There are companies those have took those kind of certificates basically from different approving authorities on the validation. So we can help you out in drafting and getting the specifications and all other documents which you can use, and then later on you can get the certifications.
Okay, that's good.
Laser scanner. Okay. The thing is, we don't have drone mounted laser scanner. With drone, we have a survey grade photogrammetry module, which allows you to get the point clouds based on the photogrammetry. And you can use it using a offshore facility on water. That's not an issue. Or these scanners like BLK 360 and RTC 360 can be carried away on an offshore site, and then you can do a scan there. The RTC 360 comes with a onboard GNSS receiver, as well as you can use your GPS receivers to geo-reference the data offshore. So these data can be achieved. You guys, I'll mention my mail ID here. So if you have any technical questions related to this or how to do this, I can explain you better way that how you can go and you can explain those kind of solutions, how you can actually run in that. But this is possible to capture all offsite projects. We have hundreds of offsite projects. Those are done using Leica scanners.
Okay, someone sent me a personal question. The person says, from my experience with Leica products such as total station, GPS, and drone, they are not user friendly, though highly accurate but cumbersome to operate when compared with other competitors. How user friendly are the equipment you mentioned?
Okay, the scanner cost how much model scanners are available. Finally, okay. So the thing is, Leica has different scanners. The normal one, the one which starts with, we can say $20,000. We have a scanner which starts with $22,000 plus the taxes which you pay in your country. Then you can go up to $100,000 based on the scanner you choose. So we have different scanners. We have the smallest one which goes to 60 meters called BLK 360, then one for 130 meters, which is 5 kgs and have a visual inertial system. You can have a 270 meters, 480 meters, you can have a kilometer range. And later on, we have our mobile mapping range, which can go up to 100 kilometers per hour. And post that, we have airborne sensors. Those can be fitted below the belly of the aircrafts, and they can scan the whole country. So starting from few meters till few hundred kilometers, we have different scanners, and we can have a discussion based on your requirements. And then later on, what we can do is we can discuss that particular project where we can go for it.
Okay. And then the first question that was asked, the person is saying that, let me read it out. It says, I don't mean scanning the elements individually. I mean scanning elements that are not visible, like say an electrical pipe in a wall or a pipe running through the floor. It's talking about
repeat again the question.
Yeah, the first question that was asked concerning scanning of as built infrastructure. So the person says, I don't mean scanning the elements individually. I mean scanning elements that are not visible, like say an electrical pipe in a wall or a pipe running through the floor.
Okay. So if you have few components, those are behind the bars, behind the walls, like you have a concrete wall, and what is behind this wall, if you want to go, then in that case, you can go with Leica see-through. We have a product called see-through. So that product can actually, if you have a concrete structure already in place, you can move that device around that particular spot, and you can find how many rebars are there, how many boards, what is the structure inside the concrete as well. So those solutions are called basically see-through. Those are penetrating radars. Those can actually tell you about the components. Those are behind or inside the construction, concrete sites.
Okay, thank you for the clarification. There was another question. It says, how much does the scanner cost, and how many models of the scanners are available?
Okay. So that's what I have explained. Like we have scanners which is 60 meters, 130 meter, 270 meters, 480 meters, 1 kilometer, and then few kilometers together. So those are different models. Like we can have based on the accuracy as well. We have a scanner called 3 millimeters accurate, then 1.8 millimeter accurate, and another is a millimeter accurate. We can divide the scanners based on the project, and the cost varies between $22,000 to $100,000 US based on the scanner you select.
Okay. Okay, I guess you could also drop your email for someone that might be interested in how to go about the process. Although I understand that 360 human virtual tours are also like your local partner. Maybe you can clarify that as well, so that people that are interested in purchasing the equipment can have a better clear understanding of how to go about that.
Yeah, so that's the reason I have mentioned my mail ID here. So if you have any questions regarding like how you want to buy the scanner, or you're facing any issues, what is the right scanner to choose, in that case, you can just straight away reach out to me, and we can have a discussion. And in that, we can actually guide you out that what is the best solution for you, how it works, how much it will cost. And then later on, we can understand your current workflow as well, that how to implement it with the cost effective way.
Okay, all right, thank you. And we have another question. It says, in view of HSE, which is health safety and all, how safe are the use of these scanners?
Okay, in all views of health and safety and all requirements, in all the sites that can be construction site or oil and gas industry, these scanners are class 1 laser based scanners. Those are completely intrinsic, and these scanners doesn't have any kind of health and safety hazards. They don't need any kind of approvals, because when you buy a scanner, it comes with a class 1 laser certification, which clearly proves that it is human safe to use.
Okay. Okay, I think we have one last question. It says, how can you georeference data obtained from your scanner?
What?
How can you georeference the data obtained from your scanner?
Okay, how can you georeference the data, right?
Yes, yes.
Okay, so there are various ways to georeference the data in this. One way is if you have your own controls installed, we can reference that data in the software based on that. Or you can even mount a GPS receiver like your GPS rover on top of the scanner in PXX series, and then you can take the geo coordinates. Third way is you can go with a GPS rover and then put one scan on a known geo coordinated position, and later on it can automatically merge all this point cloud and make it on a georeferenced data. So when you come back from your site later on as well, you can georeference it if you have some particular corners or the control points where you have the geo coordinates available.
Okay. I still saw one more question. It says, imagine scanning under a platform and the area is waterlogged. How can one imagine scanning under a platform, maybe a waterlogged area or something? How can one set up the equipment under the platform?
I'm really sorry to say your voice is staggering. So if in case I can get this question, because I'm trying to see. Okay, imagine scanning a platform and the area is all waterlogged. How can one set up the equipment
Yes.
under the platform? Okay.
Yes.
So in all those cases, if this is the area is all waterlogged, in that case, you have choices like you can put it on a boat, you can put it on a kayak, or you can have all other different bases where you can install. But the another way is you can use a long range scanner like P50, which has a range of kilometers. So you can go on top of a building, which is, we can say, 100 meters or 200 or 300 meters away from the water logging site. And then you can actually, from there, you can scan the area. And it will be accurate because the laser got a range to scan everything up to 500 meters or a kilometer range. So even if you put your scanner on top of a building which is near to the waterlogged area, around, we can say, 100, 200 or 300, 400 meters away as well, you can still get the data in laser, and then you can have the analysis. So you need not to go there. If it's a seaside or you have a container ship or something like that, you have a big vessel which you want to scan, then in that case you can bring the scanner directly on the vessel, and then there you can perform the scan.
Okay. Thank you very much for the clarifications. I guess there is no other question left. So thank you so much for the presentation. I'm sure that
if in case you have any questions, you can reach out to me on my web mail, or you can reach out to you and we can get back to you by mails.
All right. Okay, so before we leave, I also like to just shed a little more light on the other firms that contributed to this presentation, because like I mentioned at the beginning, this is a joint effort between Blaze, 360 Virtual Tours, and Leica Geosystems. So I'd just like to share a little slide on what we do at Blaze and how that could also contribute.
Surely we will have it.
Okay, so of course, as you have already known, this is the fourth out of our series of webinars we've been doing, and the essence was to share knowledge, especially in these trying times that we find ourselves in. So, Blaze as a company is a technology integration firm centered on BIM and other emerging technology in the industry. So, quite branded of services centered around awareness, like the webinars we've been doing, the form of awareness where we share ideas and knowledge. And of course, we also offer training services on various tools and BIM processes. And we also work with other architecture engineering and construction firms to render BIM execution planning services. And we also help firms to integrate solutions like software, hardware, and whatever solutions that will aid them to work smarter in their day-to-day activities. And of course, for some firms that might not have the liberty of time, we also offer design services where they can outsource their design, maybe BIM modeling services, and we could help them to come up with things like that. Perhaps a service like this could create a point cloud and could help you convert the point cloud to a BIM model and similar other services. So basically, our services is centered around BIM and other emerging technologies in our industry. And this webinar is just one of the ways we thought to keep ourselves active and perhaps implement some of these solutions during this period, because the fact that we are all at home doesn't mean that we pause everything we are doing. We still set up some remote working and collaborative efforts to aid what we do. And on the other hand, 360 human virtual tours, they're supposed to have presented what they do as well, but they are more or less local partner of Leica in Nigeria, and they already have some of these equipment in place. So they offer other services related to scanners. They help real estate firms to scan the existing properties. For real estate property providers, they help them to scan their properties and help them generate a virtual tour of the facility per se. And of course, they could also help with creating of point clouds and all that. I believe they have one of them here, so perhaps you can actually unmute his mic to tell us one or two things about what they do so that we can round up the session.
Yeah, thanks, Oyema. I mean, you've pretty much captured everything we do. So we work closely with Leica Geosystems in Dubai, and we also provide 3D scanning services in Lagos. I'm sure a lot of people, because I've heard this before, some people say, oh, are there people offering their services in Africa? So, I mean, just to point out, there are a couple of companies that offer these services. We already have some of the hardwares. We don't have everything, but we have some of the hardwares that we can use to support your project. And we're also working with Blaze as well on some of the things they do. So that's pretty much from us.
Okay, thank you very much. I was speaking, I didn't know I was on mute, actually. So before we leave, I got one last question here. The question says, how long does it take for a 1 kilometer range scanner to fully record? So I guess the question is directed to Dr. Satendra. So that should be the last question for today before we close session.
No problem. So if you have a kilometer long scan, if you want to do with a BLK 360, the smallest scanner, it will take around, we can say, roughly 20 scans, and that will take you around 60 minutes, an hour's time. If you go with RTC 360 solution, a 130-meter range scanner, then probably you will end up doing the 1 kilometer survey in 25 minutes. And if you are using a kilometer range scanner P series and you have a very high ground from where you can run the scan, then probably you can get the whole data in around, I can say, 10 to 12 minutes based on what positions you select, depending on that. As well as if you are using a mobile mapping solution, then for a kilometer, you need to drive at a speed of, I can say, 25 to 30 kilometers per hour, and it will hardly take you, I can say, 2 minutes to 3 minutes to capture the data.
Okay, thank you very much for the clarification. And we are grateful for your time to have come to explain to us on laser scanning as regards AEC. And for anybody that joined in late, the recording of the presentation will be made available to everyone, and it will be available on our YouTube channel latest by tomorrow. So the link will be sent to you, but if you also want to watch the previous webinars, or you can take up at any time, if you go to YouTube, just search for Blaze Academy, and you will see all the various sessions we've been doing, and even you can subscribe so that whenever we add any new video, you'll be automatically informed. So, but the link will be sent across to everyone. latest by tomorrow. So thank you very much to everyone. If you have any further questions, feel free to either send to us or direct it to Dr. Satendra. This is the end of this webinar. We hope we'll still communicate to everyone on our next, what our next webinar will be, because we do this once every week. So just keep an eye on your email. We'll inform you on what the next topic and the presenter will be. Thank you all for your time.
Yeah.
Thank you.
Thank you all. Have a nice day.
Yeah, have a nice day.
Thank you.
Thank you very much.